sklearn, model selection, repeated K-fold. Description. Repeated K-fold is a cross-validation iterator that implements repeated K-fold cross-validation. This method splits the data into K-folds and repeats the splitting process n repeats times. Each repetition uses a different random permutation of the data. The result is that each data point is used for validation exactly once in each repetition, and for training K1 times. This helps to reduce the variance of the performance estimate, especially when the data is small. Inputs. N splits number of folds in each repetition. N repeats number of times to repeat the splitting process. Random state for shuffling the data. Outputs. Train index indices of the training set for each split. Test index indices of the test set for each split. Steps. Split the data into K-folds. Repeat the splitting process n repeats times, shuffling the data randomly each time. For each split, return the indices of the training and test sets. Metrics. Accuracy ratio of correctly classified instances to the total number of instances. Precision ratio of correctly predicted positive instances to the total number of predicted positive instances. Recall ratio of correctly predicted positive instances to the total number of actual positive instances. F1 score harmonic mean of precision and recall. Area under the curve AUC area under the receiver operating characteristic ROC curve. Visualization plots. Confusion matrix visualizes the performance of a classification model by showing the number of correctly and incorrectly classified instances. ROC curve plots the true positive rate against the false positive rate for different thresholds. Precision recall curve plots the precision against the recall for different thresholds. Fine-tune parameters. N splits adjust the number of folds to find the optimal balance between bias and variance. N repeats increase the number of repetitions to reduce the variance of the performance estimate. Uncertainty methods. Bootstrapping resampling with replacement to estimate the variability of the performance metric. Cross-validation repeatedly splitting the data into training and test sets to estimate K. Generalization error. Challenges and fixes. Challenge 1. Oversampling in certain folds when using repeated K-fold. It is possible that some folds may end up with a higher proportion of certain classes than others. Sample use case that resulted in challenge 1. A dataset with a significant class imbalance, where one class is much more frequent than the other. Fixes to challenge 1. Stratified K-fold. This class creates folds with an approximately equal proportion of each class in each fold. Class weighing. This can be used to assign different weights to different classes, reducing the impact of class imbalance. Challenge 2. Limited data availability when the dataset is small. Repeated K-fold may result in very small training sets for certain folds. Sample use case that resulted in challenge 2. A small dataset with only a few hundred samples. Fixes to challenge 2. Increase the number of repetitions. This will ensure that each data point is used for training more times. Use a different cross-validation method. Consider using leave one out cross-validation LOOCV, which uses a single sample as the test set and all other samples as the training set.